This is take 3. I'm going to preface this by saying that a lot of these I did not implement because my implementation is different. I'm not using seeds, so none of these are going to be implemented. I did not make it adjustable yet. It is not. It's not instantiating random tiles. Although like this would be easy to implement afterwards. The array is exposed to the designers. Well, the array isn't actually exposed to the designers. However, you can tell it which tiles to spawn. This is not done. So my plan is the tiles are going to be completely coupled to the enemies on top of them. So you're going to have a enemy tile number 3, which has like a patrol enemy going around it, or an enemy tile 4, which has a guard enemy, and maybe it has a pickup health on it. So, yes, they're all going to be coupled that way.
Like the character?
This is implemented differently. The player is spawned at the spawn tile always. And the spawn tile is the first tile created.
Cool. I know that.
Enemies are not spawned at random positions. Enemies are spawned with spawners, which the spawners will be inside of the tile prefab stuff, which I haven't created yet.
Oh, that's cool.
Yeah, same thing. This is going to be coupled into the tile prefabs.
With the timeline for the anime, so.
AIs can pick up the pickups. However, I'm not going to be showing that off. Yes. Pickup power-ups don't use inheritance. However, the effect interface is sort of like that.
Yeah.
Okay. Let's show this off. So, first of all, this is the room start tile prefab. Inside of the room start tile prefab is a player spawn. In this script, all this script is doing is it's telling the game manager to spawn the player in this position.
Yeah.
Another thing, this scene also has spawner object. This spawner has a spawner script.
Oh, that's so funny.
The spawner script, all the spawner script is doing is it has a game object
That's
prefab.
So
in this one, it's the money pickup. And it has, so this spawner is a state machine. It has 2 states, spawn and spawn timer. It's stored inside the current state variable. If this is in the spawned state, then this object is checking the current object that it has spawned, and it's checking to see if it's null. If it's null, it'll switch to the spawn timer. Now, the spawn timer is just a timer. It's this length. It's a timer of this length that when the timer's up, it's going to spawn up the prefab, set the current object to that spawn prefab, and then spawn it. That's all this is doing. So if I open this up and I play, it'll spawn a money pickup. It'll spawn it 2 times, and it won't be endless. And the time between spawns will be 3 seconds. So if I play this, the money pickup's in the ground. Let me move this up. Here we go. Alrighty. So if I walk into this, I've picked up 5 coins down in here. Now it respawned, and if I pick it up again, the spawner has destroyed itself. So there we go. I'm not going to bother showing off the endless functionality. That should be, well, I'm going to have to show off the other effects anyways. So let me show the pickup system. So inside of a pickup, if I remember how this works, the pickup only handles the on trigger enter and the application of the effect. I have decoupled the pickup from the effect, and so when it comes to pickups and effects, there is an effect receiver and there is an effect interface. So the effect, I thought this was an interface. I guess this is just a class. The effect class has a bunch of information. So it has an end time float. It's got these aren't the things I'm looking for. It's these. Okay, here we go. Yes, the effect has a virtual apply, a virtual undo, and a virtual bool for whether it can apply or not. So all of these are overridden in its children. So if we have a effect underscore speed, first I gotta say I refactored a whole bunch of the movement again. Now I have a custom structure for the movement values, which just stores a whole bunch of stuff. If I go to this and if I open up my prefabs, you'll be able to see this better. Where is the speed pickup? Here we go.
Wait, already?
Here we go. So this new move variable is storing a whole bunch of just movement stuff that my tanks use, and that's been encapsulated in this new structure called movement values. So what effect underscore speed does is it's literally just replacing my current the target's receiver's tank movement values with the new movement values, and it's also saving the default movement values. So this way, if I tell this spawner to use this speed pickup, so this way what happens is I run into this, gives me the speed boost, and now I'm super duper fast. It will eventually unapply itself after a little bit longer. There, now it's undone. You can see down here it says it's undone. And it can only do that because it remembers the defaults. There's most likely a better way of doing that. I imagine movement itself should have a state machine, but this way every speed pickup could have its own speed information. Another thing I did, which is really complicated, is if you let's say you pick this up and now my movement values are reading really fast. If I pick it up again, normally what would happen is the default movement values would glitch out and it would think I'm always super fast. But it's passing information in a way that it still has the default, the true defaults. Hopefully I can show this off. When it undoes the effect, or not, when it undoes the effect, it's just setting the movement variables default move vars to the default move vars. But when it's setting the default move vars, it's caching the default movement. It's choosing to either cache the actual tank movement, default movement, or the receiver's movement, because the receiver has its own effects list. And if the receiver already has a speed effect applied, this new speed effect is going to be getting the movement variables from that speed effect instead of the receiver. Hopefully that made sense. Let me show off my other pickups. You already saw the money pickup. It actually works with a wallet system, which is just a very crappy inventory. If I go back to scenes, spawner, let me give it medium health pack. Yes, spawner, medium health pack. Boom. I'm gonna tell this one to be endless. I'm gonna pick this up. 50 health. Yay. Now my tank is at 52 health. You see, it spawned at 2 health. Now my current health is 52. If I pick this up again, now I'm at 100 because it clamped. And since this was endless, it keeps spawning. And it tells me effect cannot be applied because I'm already at full health. Awesome. I hope that was enough for the pickups and effects system. That's essentially how it works. So I have these prefabs, which this prefab is, all it is it's a pickup script. It's just a pickup script. And then it has a factory inside of it that tells it which pickup to use. And so if it's set to speed, it's going to create and apply a speed effect with these variables. If If I set it to money, it's going to create a money effect with these variables. But this one was originally set to heal, so I need to set it to heal, and the heal amount is 50 for this medium pickup health. Yeah, so all of these are literally just a game object with a pickup attached to it, and inside the pickup, these prefabs are telling it which effect to use. So in a sense, it's decoupled, but it is still highly coupled because the prefabs need to tell it which ones to spawn. All prefabs are going to be made anyways, regardless of whether it's coupled or not. I'm going to show the map generation now. Wrong one. Here we go. Okay. You'll notice this is empty. So, hopefully I can explain to you the way my map generation works. There's a room and a map generation. I'm going to first show off the changes I made to the room. So, the room now stores a list of door states. And the door state is just, it's an enumeration for whether it's open, closed, or if it's a secret door, or if it's a locked door. I haven't implemented those yet, but that's there in case I want to implement that. So, it's basically just going to, when it's awake, it's just going to set all these doors that you set in the outliner equal to the array locations. And another thing, 0, 1, 2, 3, and 4, or, well, 4 is not on here because these are array indexes. My cardinal directions are equal to integer values. So 0 is north, 1 is east, 2 is south, 3 is west. That's actually not entirely true because these are indexes in an array. Preferably 1 would be north, 2 would be east, 3 would be south, 4 would be west, but arrays start at 0. So these are all minus by 1. In actual generation script, it goes 1 is north, 2 is east, 3 is south, 4 is west. I should have done it a different way, but that's how I did it. So this has to conform to the array stuff. Anyways, they have a set doors function inside of this room component, which is just going to take another list of door states, and it's just going to destroy the doors if the door is closed, or open, I should say. Okay, so now I have to explain this. I'm not actually going to go through all of this, but I have this giant list, this giant comment up here that sort of explains it very well. So you can think of my generator as a snake. It's going to start and spawn a, well, I should start with the grid. So this, or I should say this. This is the most important thing in this map generator. It is a list of lists of tiles. Now, tile is simply a special structure that encapsulates the coordinates, the prefab, and the door information. This map is a list of lists of tiles. And instead of starting with a map of like 5 by 5 map, it's always going to start with a 1 by 1 grid. And the first thing that's going to be applied to it is the starting prefab. So the start tile is always going to be the starting prefab. And so instead of having a large grid at the beginning and then filling it all up, a large empty grid and filling it up, this is going to be a single grid, a grid that can be extended upon, and it does. So the way this works is I have separate things called generation path objects. And in my gen path objects, here we go, the gen path objects, what they do is they create a random direction and they move in that direction. Then, if the 2D map array needs to be extended to fit that direction, it does. Because the list doesn't include that yet. I don't know how I can explain this in a way that makes sense without taking an hour. There's So there's two different types of integer indexes and coordinates. There are the coordinates, and then there are the indexes in the map list. Because you can have a negative coordinate, but you cannot have a negative index. So I had to create a bunch of stuff. I'd probably not be able to find it. That turns. Yes, here we go. It turns coordinates into indexes and indexes into coordinates. First of all. Then, and now remember, if you try to add a new column to this, it's going to add. It needs to know how large and long that column is. So whenever you expand the array, whenever the generation paths expand the array, it's like creating empty grid spaces. So when it starts, it's a 1x1 grid. Let's say it moves up 10 times and then right once. Now you're going to have a 2x10 grid. A lot of them are going to be empty spaces. The 9 things on the right are going to be empty spaces. If that makes sense. So they're then going to place a random tile prefab in this index. Now, it's not actually random yet. It's always just going to be the tile prefab for now. I could turn that into a list, but I don't have enough time yet. So whenever a gen path creates a new tile, then it's going to do the logic for opening and closing the correct doors, although it doesn't close any doors. All the doors are closed by default. It's just opening doors. Again, so if a gen path moves into a tile that isn't empty or null, it's just going to open the door instead of replacing it with a new tile. And so the gen path does this over and over and over again until it's placed enough tiles. And then the last tile it places is always going to be an end tile. So now that the 2D tile array is filled with tiles, it has to instantiate them. So these are, remember, tiles are just it's a data structure that stores a prefab, a coordinate, and door information. It then has to instantiate all of that information. So this is a tile array. Now it has to instantiate all of those tiles and then open the doors. So the reason I did it this way was just because I wanted it to be more controllable. Although there's a lot of overhead in making this system, obviously. It would have been a lot easier to just make a 2D array of empty grid spaces and then fill it with random tiles, I should say. But this system, what I can do is I can create a whole bunch of special generation paths that branch off from one another. So if we think about like Enter the Gungeon, I could create a chest path that branches off at some point and starts and always ends with a chest room. So in Enter the Gungeon, every dungeon has 2 chest rooms. So I could do that. I can implement that in this. Another thing I could do is I could have the end tile locked. I could have all the doors require a key to get into it. And then I could have a special generation path that ends with a key room, which gives you a key. So, pretty neat. I don't want to go over how this works because that would be way too long, and I probably would not be able to explain it. So, I'm just going to show it. All right. So, we have now generated a dungeon. The start tile will always be at 0, 0, world space. However, if I keep running this over and over again, you'll see it's just going to keep giving me random stuff. Now, it gave me a dungeon that looks like this. Let's get another one. Ah, now I got this dungeon. So instead of a square, it could be like any shape. Currently, it's only using one generation path. It's not branching off yet. So this one is probably going like around this way, and then it's going around that. So I could implement more gen paths, but I don't have enough time. Anyways, let's play around in here. So all of these are just normal tiles. They don't have I haven't implemented any random tiles selection yet because I didn't have enough time. Hopefully I can even upload this in time, because currently it is 11:30. This might be the end tile because it doesn't lead to anywhere. Or maybe it went backwards through here. Pretty nice dungeon. I really love the system, although there's a lot of overhead in creating it. I want to start unit testing a lot of my variables I make, and I want to be smarter with the way I make them, because a lot of things I make are actually methods instead of just properties or variables. And those methods need to be unit tested, because when I'm tired I code and make dumb mistakes. Let's get another dungeon up in here. What does this one look like? This one looks like that. Go right. Now I can go forward or left. Now imagining there's enemies here. Maybe every tile is gonna spawn like a enemy tile. It's gonna have like random enemy spawns. Using the spawner, of course, because the spawner can take any object. It doesn't have to take a pickup object. The spawner can take AI prefabs and spawn them as well. And then when the AI prefabs are null, it spawns another one. Or if I have it set to just spawn one, the spawner destroys itself after it spawns it. So, imagining there's enemies in here, and maybe there's even barricades and pickups to pick up. Kill an enemy, they drop money, you can pick that money up before it disappears, and got a pretty nice game on our hands. Of course, I actually want the turret on top of the tank to rotate around with mouse movement. However, I haven't gotten to that yet. This is very fun. I love making systems and then having them actually work when they're implemented. Something about the logic. It's very beautiful. Alright, I gotta turn this in now.